This video is for Math 70, and this is the second assignment for solving systems of equations. And the first one, we talked about solving systems of equations by graphing, and now we're going to talk about solving systems of equations by substitution. And then in the next assignment, we'll talk about a third method for solving systems of equations. All right, so we look at problem number 2 on the assignment. Let's see, we got x minus y equals -3 and y equals 3x plus 5. Now there's no reason why you can't solve this by graphing it, but it's good to learn all of these methods because some systems lend themselves to a particular solution. So here, what we can do is replace the y in this first equation with what y is equal to in the second equation. And so that would generate a new equation that says x minus parentheses 3x plus 5 equals -3. And those parentheses are important because now we have to distribute that minus into the parentheses. And so that'll give us -2x minus 5 equals -3. And then we'll add the 5 over to the other side. -2x equals 2. Divide on both sides by -2. And x is -1. And then we'll come over here and replace the x with -1. And so that'll be -3 plus 5. So y equals 2, x is -1. If we want to write this as an ordered pair, we can write it as -1 comma 2. And we can also double check to make sure that these are true. So if x is -1, y is 2, is that -3? Yes. And let's see, if x is 2 and, if y is 2 and x is -1, is that true? And yes, it is, because we just generated the solution from that equation. Okay, so that's the process, is to isolate one variable. In this problem, the y was already isolated. So we isolate a variable, and then we plug it into the other equation. Okay, let's look at problem 4. Our first equation is 3x minus y equals -1, and x equals 2y minus 7. Okay, so let's take what x is equal to, plug it in for x in the first equation there, and now we can solve for y. So again, we have to distribute 6y minus 21 minus y is -1. So that's 5y minus 21 is -1. Add the 21 and divide on both sides by 5. And so y is 4. And then we'll come over, plug the 4 in here. Turns out x is equal to 1. So x is 1, y is 4. If you wanted to write it as an ordered pair, you would write it 1 comma 4. Okay? Let's see what else we've got here. All right, let's look at problem 8. 2x minus 3y is 17. X equals -y plus 6. Okay. Same process. Plug in the minus y plus 6 for the x. And now it's just a regular linear equation. So we get -2y plus 12 here. Now, when you're combining these terms, these like terms, you've got a negative 2y and a negative 3y. Together that's going to make negative 5y plus 12 equals 17. We'll subtract the 12 on both sides. Negative 5y is 5. And so y is negative 1. And then we'll plug it in over here. So again, this negative comes with the equation. This negative comes from the value of y. So that's going to make this positive 1 plus 6. And it turns out x is equal to 7. And we can double check this. 2 times 7 minus 3 times negative 1. Is that 17? Yeah, 14 plus 3 gives us 17, because this and this make a plus. And we can check it in the other one, but this is the one that we generated the value for x from, so it really is going to check out 7. So 7 equals 1 plus 6. Yeah. Okay. So in those problems, one of the variables was already isolated for you. Now we're going to look at some problems where we have to do that ourselves. Okay, so problem 10, and this is not so terrible. X plus 2y equals negative 3. 3x minus 2y equals 7. So I think it's helpful to look at the equations. If you've got just an x here, then that's a good variable to isolate. Okay? We can move the 2y to the other side and say x is negative 2y minus 3, and then we'll plug that in right here. Now, don't plug it back into the same equation you just used, because it's not going to generate a solution. Okay? If you want to talk to me about that, I'll be happy to talk with you about it. But if you isolate one equation, you have to plug it in to the other one. So 3 times negative 2y minus 3 minus 2y equals 7. So negative 6y minus 9 minus 2y is 7. Combine those like terms to make negative 8y. And then we'll add 9 to both sides. Negative 8y is 16. And so y will be negative 2. And then, let's see, we'll plug it in right here. And it doesn't matter where we plug it in. Let's see here. So that's going to be 4 minus 3, which is 1. So x is 1, y equals negative 2. Yeah, okay. So, like I was saying, you know, it's a good idea to isolate this x, because that makes it easy to then just go and plug this in. We could have isolated the y, we could have isolated x or y in this equation. I'll run through that and just show you why I made the choice that I did, is because I find it easier. Okay, so let's take this equation and isolate the x. 3x minus 2y equals 7. So we can add 2y to both sides. But then we've got to divide everything through by 3. And so our substitution here comes out as 2/3 y plus 7/3. Not the end of the world, but then we come up here and plug it in, and we've got all these fractions to work with. So let's see. This is 2 is 6/3, plus 2 more thirds makes 8/3 y. And then we've got to subtract 7/3 on both sides. And so over here, the 3 is negative 9 over 3. So negative 9 over 3 minus 7 over 3 is negative 16 over 3. And whether you divide by 8/3 or multiply by 3/8, y equals -2. So it's the same answer. There's nothing wrong with it. So that's the thing, though, is that if you've got a coefficient in front of these variables, it can make your substitution a little bit trickier. Okay? So that's why I made the choice that I did to isolate this x up here, is because that allowed me to calculate or solve with whole numbers. Okay, let's see what else we have here. Problem 12. We've got 5x minus 2y equals 7. 5x minus y equals 6. Now this one, just from its format, you might, since these 5's are the same, you might look at this and be like, well, let's see, if I'm subtracting 2, I'm going to get 7. If I'm only subtracting 1, I'm going to get 6. It's kind of hard to recognize right off. That says to me that y is going to be -1. But let's go ahead and isolate. So first off, here's a variable without a coefficient. It does have a -1 in front of it. So maybe I'll add it to this side and then subtract the 6 over. And so y is 5x minus 6. So then I'll plug that in up here. 5x minus 2 times 5x minus 6 equals 7. All right, so let's see, 5x minus 10x plus 12. So -5x plus 12 equals 7. Subtract the 12 on both sides. And x is +1. So if I plug in the +1 over here, then that gives me 5 minus 6. And yeah, it turns out y is -1. Okay? All right. Now, these problems towards the end of the assignment, there's a little bit more work involved. Let's see, let's look at problem 16. 4x minus 3y is -3. 2x plus 6y equals 1. All right, so now, number one, we don't have a variable that's been isolated already, and all of the variables have coefficients in front of them. So, there's what I'm saying is that there's really no easy way out. So, let's see, I will subtract the 6y on both sides in this equation. 2x is -6y plus 1. And then don't forget, when I divide through by that 2, you've got to divide everything in the equation by 2. So that'll give us x equals -3y. And whether you call it a half or 0.5 doesn't really matter. If you like decimals, you can just put a 0.5 here and calculate with that. That's fine. But the key here is that now we're going to take this and we're going to plug it in to that first equation in place of x. So let's see here. 4, -3y plus a half, and then -3y equals -3. So that'll be -12y plus 2 minus 3y, excuse me, equals -3. So again, we're going to combine our like terms here, the -12y, the -3y, that makes -15y. Subtract the 2 on both sides, -15y is -5. Now this is a place where I see a lot of people make the mistake of they think, oh, I can't divide by a smaller number by a bigger number, so they divide both sides by 5 and they say y equals 3. No, that's not what's going on here. We want to get the y by itself. We have to divide by the coefficient in front of the y. And so over here, 5 over 15 is 1/3. There's nothing wrong with that. If you're ever not sure, we can go back and we can check our answers, okay? So let me calculate the value of x, and then I'll check out the answers over here. So what I'm saying is don't get freaked out if you get an answer that's not a whole number. There's nothing wrong with that. All right, so x is going to be negative 3 times y plus a half. So that's going to make this negative 1 plus a half, which is negative 1/2. So there's our solution. X is negative a half, y is 1/3. Let's check our answers. 4 times negative a half minus 3 times a third, is that negative 3? That's negative 2 minus 1, negative 3. Good. Okay. And we also want to check it in the second equation. 2 times negative a half plus 6 times a third, does that equal 1? Negative 1 plus 2, yep, 1 equals 1. So the answer checks out. The fact that these are not whole numbers is really not important. Okay? So that's problem 16. I'll look at the couple more of these. All right. Problem 18. X minus 2y is 15. 4x plus 5y is 8. Okay. So, well, this is nice here. After that last equation, you can see sometimes the difficulties we have if we have a variable that has a coefficient in front of it. And so I'll just get the x by itself here by adding 2y to both sides. X is 2y plus 15. And then I'll plug that into the second equation. So, distribute the 4 into the parentheses. 8y plus 60. And so this will be 13y plus 60 equal to 8. Subtract the 60 on both sides. And then divide on both sides by 13. Y is negative 4. And then I'll plug this in here. 2 times negative 4 plus 15. And so x is 7, y is negative 4. All right. I think we've just got one more to look at here. Problem 20. Okay. And this one also has a variable that is pretty easy to isolate. 3x minus 6y equals negative 8. So I'll isolate that x in the first equation there by adding 3y to both sides. So x is 3y minus 6, and then I'll plug that into the second equation in place of the x. 3y minus 6. And then minus 6y equals negative 8. Distribute the 3 here. 9y minus 18 minus 6y is negative 8. So that'll give us 3y minus 18 is negative 8. Add the 18 to both sides. So 3y is positive 10. And y is 10/3. If you prefer decimals, then be aware that this is a repeating decimal, and so if you want to calculate with it, like if you want to plug it back in here and use your calculator, put a string of 3's out there, 7 or 8 of them, something like that. That allows the calculator to understand that you're working with a repeating decimal. All right, let's see here. So 3 times 3.3 repeating minus 6. Now here's the thing, if you're going to work with these, then you should understand how they work. So if you want to do 3 times this on your calculator and you put a bunch of 3's in there, well, let me check it out and see what the calculator does. Because it's either going to say 9.99999 or it's going to say 10. Put in those 3's and let's see, how many did I put in? 6, 8, 10. I put over 10 of them in there and I got an answer of 10. Let's see, what have I got up here? 7 of them. Now if I do that, okay, so actually let me erase that 10, because if you type in what I've got written up here, what the calculator returns is this. Okay, one more. All right, now that first calculation I made, it was, you know, I wasn't counting, I was just hitting the button over and over and over again, and when I got enough of them in there, it understands. So what I'm saying here is that if you only do this and you get something like this, be smart about it. This is 10, okay? That's what the calculator's telling you. 10 minus 6, x equals 4. Okay, let's go ahead and check our answers before we wrap things up here. I always like to do that if I don't get a whole number, just to double check things. So, 4 minus 3 times 10/3, is that equal to -6? Well, these 3's cancel, or if you do 3 times 10/3, you should get 6. 3 times 10/3 is 10. There we go. And so, yeah, -6 equals -6. That checks out. Let's do the other one. 3 times 4, 6 times 10/3. Is that equal to -8? So that's 12. That'll be 20. And yeah, there we go. -8. And so it checks out. All right. So that's it for this assignment. Like I said, we're going to have a third assignment, a third method of solving these systems of equations, and then we will look at some word problems. So, as always, if you have any questions on this, please let me know. Thanks.